Hi, I'm Soo-young Kim from South Korea Load Balance, and today I will show you how to recognize such an handwritten or printed digits with NVIDIA's Jetson Nano and just ordinary webcam. And I will not focus on deep learning theories or mathematics, but I will just show you how to utilize my codes. Let's get it started. In this video, I prepared total 3 examples. The first and second example use the Google Collaborator, and the last example uses the Jetson Nano and webcam. All the code file settings and description for the last example can be found from Load Balance Educational website. So let's start with the first example. The first example is to recognize handwriting and printed numbers using a very simple neural network, an MNIST Dataset. If you click this blue button from my GitHub, Google Collaborator will automatically run, and you can learn the example immediately. So let's click this button. If you learn this example, if you don't want to watch this kind of warning, click the file and save a copy in your drive or save a copy in your GitHub. I will just click Run Anyway for now. Next, change the hardware from the CPU to GPU and click this runtime and change the runtime type button. And from the hardware accelerator, you have to change your hardware from CPU to T4 GPU and click the Save button. And I learned all codes by clicking this button, runtime, and restart session, and run all button. Yes. Yeah, as you see in here, you can watch this Google Collaborator is doing something training for neural network. And finally, it's done. And if you click the files icon on the left side, you can watch this kind of model underbar test.pth file has been created. And that's exactly the file that is containing model information and train parameters. You can download this file manually by clicking these 3 dots and download button, but you can use this PTH file from my GitHub too. I have published this file on my on my GitHub, and you can see this. This is exactly the file. This is exactly the same one in here. So we just finished the first example, and we got the PTH file. Let's move on to the next example. Learning the second example is the same as the first. If you click this blue button, Google Collaborator will appear and you can learn the examples immediately. But the object of the second example is to inference new data with a pre-trained model. So we need a PTH file that we made before. In addition, we need new data, digit images in this time. Therefore, I have already added the PTH file and several images to the workspace like this. It is simple to add a file to workspace. You can drag and drop from the file explorer to Google Collaborator workspace like this. Just ignore the warning. Next, let's change our runtime type from the CPU to GPU like this. And let's learn whole codes at once by clicking the runtime and restart session and run all. For the execution of the code, I have added a codes for verifying the PTH file and image files like this one. So make sure that no errors have occurred in here. You can watch the error code if there are not the PTH file. And in this time, now this cell says that keep going. Let's keep going. In this code, you can watch the well-recognized images that says this one is 7 and this one is 2. Let's keep going. Let's check if our model recognizes well, even if we use the new image files. And this is test6.jpg file and this image. As you see here, it is predicted well. Now it says this number is number 6. But if I change this image path from test6 to capture 8 looks like this one. Yeah, let's run this code again. Unfortunately, now our model says that it is number 9, not 8. The reason for this is because we use the simple model. So in our next example, I'm gonna do the same thing again with the CNN model. In the third and fourth examples, I will trade and inference needed images again by changing our neural network model to CNN. The process is exactly the same as before, so I'm gonna press the blue button and run the Google Collaborator. And this example will take more time than before, therefore I have already run all codes to save time. As you see in here, you can watch the pre-trained and created CNN underbar train underbar model.pth file. You can download manually, or you can use the file that I published on my GitHub in here. So now let's move on to our next inference example. Finally, the fourth example. In the previous second example, in here, image 6 recognized it well, but mistakenly recognized image 8 as 9. So let's see if this can be improved with the CNN model. The fourth example is also an inference example, so I added a PTH file and several images to workspace. This time, let's run the code cells from the top one by one. Run the cells and run the cells, move to the bottom, move on. Yeah. Let's start with demo 3 first. Demo 3. Now it says this is number 3. Works well. And next one, test 6. It also works well. And finally, capture 8. Which one has failed before? Yes, now it works well and has improved. So using CNN, you can see that the performance has improved like this. And finally, let's move to the real-time number recognition example using Jetson Nano and webcam. This cell you see here is an example running on a Jetson Nano, and the Jetson Nano setting for this example can be found in the load balance educational homepage. First, please make sure that the device you're using is established as a CUDA, that is GPU, and the model used is the CNN model we used before. And before running the inference, you must place the pre-run PTH file in the correct location. In my case, I have this file in the home and documents folder. Next, please check the log keep going as below and move on to the next cell. Now, before I get the image from the camera, I'm gonna check if the camera is connected well. As you see in here, the name is video 0. Therefore, you can watch the code capture device equals 0 in below cell. If you run this code, it'll take one image from the camera and save it. So make sure that the image has been successfully saved, as you can see here. And let's move on to the below and below. Yeah, this is the last one, that the code for real-time inference. And run this part, I mean the interactive cell first, and then run the below cell that named execute cell below. After a little loading time, you can check the results in the cell right above again, in here square box. And next, I'll show you the actual demo video. Here are pictures of a football player, and traffic sign, and car license plates. And finally, a printed numbers and handwritten numbers. I prepared several images to show you what kind of numbers my example can actually recognize. Next, let's run an example. Printed numbers are recognized well like this. And that's for handwritten numbers too. Just so you know, it recognizes black numbers on a white background well. The car license plate shows a little bit of errors. Next, you can watch the recognized traffic sign and the uniform number of the football player. That's all for this video, and once again, you can find the setting tutorial and whole code file for the last example in Load Balance Education site. So thank you for watching, and don't forget to like and subscribe. I'll be back with more practical and useful Jetson examples. Thank you.